Hello. Today we're going to talk about how we at IBM use a secure by default approach for software engineering and our ability to support secure software engineering supply chains using the IBM ShiftUp platform and product engineering service and through the use of Rancher and SUSE products. The agenda for today is we'll start with an introduction of ourselves, then we'll go into how we deal with compliance in the federal government marketplace, and then go into our specific solution that we created to help solve our secure by default issues within the federal marketplace, as well as solve a lot of our platform engineering capabilities as well. We'll give a demo of that, and then I'm going to turn it over to my partner, John Chanfaglione, who is going to go into our secure by default architecture and the toolkits that we use from SUSE and Rancher that make up our ability to perform this work. My name is Mark Wells, and I run the IBM Federal CTO Center of Excellence for DevSecOps and Cloud Native Engineering. And I am supported by my chief architect, John Chanfaglione, who will cover in detail how we use Rancher tools to meet extreme security policies and mandates through advanced automation. Within the federal government marketplace, we are burdened with a plethora of security standards, policies, and mandates from a never-ending source of agencies that assess, authorize, and inspect our work at every turn. This level of control usually results in development teams spending 80% of their time on cybersecurity and sustainment and only 20% on new development. This is not an effective or efficient model for business or government, so we needed to find a fix for this situation. So we did. We decided to minimize the level of effort for developers by building a platform that automates to the extent possible everything we can to make the life of the developer as easy as possible while still maintaining all the necessary controls for security and performance. ShiftUp was the outcome of that plan, and the idea of continuous everything was the approach to that plan. ShiftUp, which is based to a large degree on the services of Rancher and SUSE, delivers that automation across the full spectrum of services needed to support a secure software engineering supply chain operation. You will notice the term on the slide called continuous ATO. ATO means the authority to operate. That's one of those assessments and inspections we were talking about earlier, where the federal government will ensure that anything that is put into production meets the required standards for security through this continuous ATO assessment. Part of the unique nature of our ShiftUp platform is how we standardize all cloud infrastructure and technical configurations through the use of what we call a deployable blueprint. We have spent a significant amount of time trying to build out the complex nature of delivering that service. The blueprint is an abstraction layer above Terraform where we describe everything that makes up a functional environment, from the VPC ingress and egress rules to the tools and databases that support the business need. Blueprints provision any cloud service along with the requirements that specify its purpose, along with the security mandates that define the environment operational parameters. Then from within the ShiftUp self-service interface, users can select the parameters that suit their needs and at the push of a button, deploy everything they need within 30 to 45 minutes. Each tenant environment deployed has all the integrated services necessary to support secure by default operations. We're now in the process of simplifying our blueprints to be based on Rancher's Hauler, where our blueprints are halls that Hauler deploys. But the real purpose behind the blueprints is standardization. Every environment, every configuration, every integration is standardized and now easily maintained and supported. But when it comes to security authorization, each environment has to be inspected by those government security organizations. The standard nature of the tenant environments ensure that one configuration has to be authorized, then all subsequent environments meet the same set of standards and policies. Because we configure all aspects of the tenant zones, we have full control over security compliance. With the use of Rancher RKE2 hardened and authorized container images, Our ability to meet standard security requirements becomes a much simpler process. Lastly, it's not possible to deliver true secure by default and secure by design capabilities without the DevSecOps environment being designed to support the security mandates and policies. We auto-deploy any kind of DevSecOps pipeline to our CI/CD tools, which includes all the inspection, scanning, testing, and security vulnerability verifications necessary to meet cybersecurity policy standards. You see from the pipeline shown that we enforce gating throughout the process to ensure all code meets required standards of practice. And then we perform security attestations and audit on the code to validate the provenance of the code before deploying to dev, test, and production. You will notice that we have 3 tiers of enforcement. At the dev level, we warn and allow the problem to persist. During tests, the policy will provide an error, but when trying to deploy to production, unless that code is fully compliant with all policies and standards, it will not deploy. We can ensure that all developed software is secure by default before it ever hits production. So with that, I'd like to give you a quick demo of what ShiftUp does. Then John C. is going to go into details about what is happening in the background.
This is the ShiftUp main screen, and I'm not going to go into a lot of details about it. We're going to concentrate on the secure by default capabilities that exist within it. But its purpose is to deploy clustered environments with all the configurations necessary to do so. And essentially the way we do that is through creating a cluster simply just by giving it a name, selecting its size. You can see the size is changing as I am changing this. And then selecting where is it going to go, AWS or Azure. Virtualized means that it's going to be going to the Rancher Harvester HCI service, but I can choose AWS. The environment is set for our demo environment. I can set the type of environment I want, and then the cluster template, which is our blueprints. And there are any number of kind of blueprints you can make. Build any number of blueprints for customers. But essentially the blueprint's purpose, as I said before, is to cover everything that is necessary to make this system functional. So on the infrastructure side, it handles everything within the VPC, from the ingress and egress, the load balancing, the gateways, the routing, the security groups, the identity management, and everything else inside. But at the application layer, this is a standard DevSecOps cluster. The standard DevSecOps cluster has upwards of 30 different applications that make up its environment. So this template blueprint has those 30 apps in it and knows how to deploy them and deploy them correctly to provide all the information, all the configuration stuff that's necessary to make it operate. So I can select that, and then I can select a security model. The security model is based on what the federal government uses, but generally speaking, the FedRAMP medium or moderate is the most common. And essentially what this says is I am going to apply a policy bundle to this environment that will enforce the security controls at that level. And so by making that choice, I can hit create cluster, and in about 30 to 45 minutes, the cluster will be ready to go. When it's ready to go, it will deploy everything into the cluster, including all the tools like GitLab and project information through our projects interface. It'll set up your registries. It'll set up other tools. We use NuVector, for example, to view the environment that's been set up. You can see the containers that have been deployed, and when those containers get deployed, they get scanned, and we also use a service that we have built along with other tools and products that exist on the market to create images that you can see have almost zero vulnerabilities. So this is part of our secure by default process, which is let's start at zero. and then go from there. So this is an example of the deployment mechanism that puts this in place and allows for my environment to be very, very secure. The second part of this is to make sure that we have everything in place to support security across the development process. So, again, talked about those policy bundles. So, on the policy bundle side, here are the policy bundles, and there are quite an extensive amount of them, and we can add more as necessary. But essentially, this bundle gets deployed into our CI/CD environment, dependent on the type of security that was chosen. And also, we showed where there were different types of levels of security. So you can see, for example, there's a baseline, there's an enforce, and a restrict for dev, test, and prod, and making sure that we can do things, for example, like disallowing privileged containers, which is important to the federal government requirements for security. So those policies act to enforce everything and make sure that they stay in an enforced state at all times. And within the applications itself, or within the development programs themselves, you can see that these pipelines, besides the build process, the pipeline, they then have the security side of the pipeline, and the security side of the pipeline will do a full inspection. So it's going to do an SBOM inspection, an image scan. It's going to publish that, but then it's also going to do a full security attestation with a cryptographic signature being applied to it, and making sure that this image is fully attested to and audited to the requirements of the security standard before it's ever going to be deployed. With that, I'm going to let John go into some of the details behind the scenes as to how these work and what's going on to make our systems even more secure by default.
Thanks, Mark. Before we take a deep dive today, I just want to talk a little bit about what we mean when we say secure by default. If you're watching this tutorial today, you probably have already heard the term shift left, and what that means in the context of DevSecOps. And when we talk about shifting security left, what we're talking about is embedding um, security best practices in our software delivery lifecycle. So maybe we've got an automated pipeline that is scanning our source code for insecure coding practices, or maybe we are building source code and embedding it in a container, so we need to scan our container for critical vulnerabilities. But literally, that is just the tip of the iceberg when we talk about securing a platform. And so we use that iceberg mentality when we talk about secure by default. And so when we look at an iceberg, everything that's above the water here is that DevSecOps pipeline. It's everything below the water that we talk about securing. And so that means your operating system, your containers, and then any of your open source packages. All of those things need securing. And so when we talk about our platform that's built on top of Kubernetes, a standard deployment has roughly 60, 80 containers, maybe 20 Helm packages, and then our operating system. None of those things can be sourced from just any public registry, and you really don't want to be sourcing those Helm packages from a public registry either. And in today's security landscape, all of this stuff is magnified. SUSE reports that software dependencies are involved in over 15% of major cybersecurity incidents. In 2023 alone, there was a 200% increase in attacks using software vulnerabilities. Gartner says by 2031, we're going to spend $138 billion mitigating these software vulnerabilities. In 2020, SolarWinds attack had heavy impacts on the federal government, resulting in a number of executive orders around cybersecurity, and resulted in this secure software development framework. So when we think about secure by default, we can really kind of distill it down into three pillars. The first is curation, and really that just means being able to verify and validate and vet the open source packages that we are using. Creation means that we're establishing a set of processes and procedures for creating artifacts. And then consumption is having processes and procedures in place for being able to validate and verify the artifacts that we are consuming. And by establishing these three pillars and processes around them, we can sort of mitigate this threat vector. And so long gone are the days of just being able to consume any sort of public container or just any sort of public Helm chart. And so for us, this is the way of the future. And on the surface, um, while it takes a lot of work, it's not too hard to do this one time, right? I can set up a cluster, I can go examine it, find out what's wrong with it, and then mitigate all of those software vulnerabilities. But how do I build a repeatable process? How do I make sure that every single time I build a cluster that it's secured? And then how do I duplicate that over and over and over again? And then how do I make sure that over time I can know every single version of every package? How can I ensure and verify that anytime I do a deployment that it hasn't been tampered with? And so this is the problem and this is the challenge that we need to solve when we talk about secure by default. Now, fortunately, we have a number of tools that SUSE has provided us that we've built some processes on top of. And so what does the SUSE toolkit look like? First, we have Edge Image Builder. Image Builder provides us a declarative way to build a consistent and immutable operating system. SLE Micro is a type of container OS. There are other flavors out there, Flatcar, Fedora, CoreOS. There are other ones out there. It's a lightweight operating system specifically for running container workloads. If you're not familiar with Container OS, go check it out. It's really cool. But anyway, we'll show you a little bit about how you build an image using Edge Image Builder. RGS Carbide. RKE2 is a great Kubernetes distribution. It already comes with few CVEs as possible. It already has a security conscious mindset. But in the federal government, we need a little bit more of a hardened posture. Two things that the government requires. One is FIPS encryption, and then the other is what's called a STIG, a Security Technical Implementation Guide. RGS Carbide provides both of those things. So we don't just deploy RKE2, we source our RGS Carbide Kubernetes distribution. And then finally is RGS Hauler, which provides us a way of declaratively packaging assets, configurations, Helm charts, containers, really anything. You can package up and build a package. Now, a lot of people, when they think of Hauler, they think of this as an air gap mechanism. And so if you're not familiar with an air gap mechanism, what that means is you don't have any access to the internet. And so you have to take all of your assets with you into the environment that you're deploying. Well, we found that that's a side effect of what Hauler does for us. What Hauler does for us is allows us to build a package where we can version every single thing in there. And then what's included in Hauler is some really interesting tooling that allows us to serve up all of these assets within our environment. And so it's the combination of declaratively defining what that package looks like and then the tooling that serves it that has really given us the ability to build this secure by default platform. And so IBM has built Grayskull, and it's this abstraction built on top of all of this tooling. And so it's two parts that feed into what a sample cluster deployment looks like. So the first part is Edge Image Builder. And we'll take a look at what that is in a moment. But an engineer on day zero will build out a series of images that represent their cluster. And that starts with the SLE Micro raw image. So you go out to your SUSE portal, you'll download your SLE Micro raw image, and then you customize it through the use of combustion scripts. You provide any of your files or assets in a custom folder, and then you can also provide certificates and other things. The certificates allow you to establish a trust between all of your nodes. And so the output of that are a series of server nodes, agent nodes. And then we create a special node called a bootstrap node, which includes the output of what we call Grayskull Stack Builder. And I'll show you how all of this fits together in a moment. Grayskull Stack Builder is a layer on top of Edge Builder on top of the operating system. Stack Builder, again, day zero, the engineer knows what their cluster deployment needs to look like. And so on top of Kubernetes, maybe I need a load balancer. Maybe I want Argo CD to do a deployment. And so I need all of these other things running on top of my cluster as soon as I deploy it. And so I will include any of the containers that I need, any of the Helm charts. Maybe I need to do some other deployments, so I might include some Ansible scripts, or maybe I'm using some Terraform to do automation. And so I will include all of that stuff in my stack builder, and I do all of that declaratively. But in addition to that, I will, in my stack builder pipeline, I inspect, sign, and build an attestation. And so what Hauler gives us is the ability to assemble all of that in a package. And then that package has some tooling around it that allows me to serve up all of those assets as an OCI compliant registry. And so I can serve up all those containers and charts, but then I can also serve up any sort of raw file. I can even serve up my images, my operating system images, but there also can be signed and attested to, so I can use standard OCI tooling to do signature verification and check attestations and do policy sort of validations. And so it's the combination of these two things that allow me to build a secure cluster. And so on the right here, you're looking at sort of a standard cluster deployment. It's not a highly available cluster. I just have a single server node, a couple of agents. RKE is using Carbide, so it's RKE, but plus all of the hardening, the STIGs, and my FIPS compliance. And then instead of sourcing just the standard RKE2 binaries and containers, I'm using my local registry, which has all of the components that I sourced from Grayskull Stack Builder served up as an OCI compliant registry, which brings us to the tutorial. So I'm going to switch out here and we're going to move into my terminal screen here. So the first thing I want to do is tree out my RKE2 agent folder. So we talked about the first component, which is Edge Image Builder. And so this folder structure is by convention. So the first thing I need to do is set up a configuration directory. And in that configuration directory, I have base images. And so this is where I would go out to the SUSE portal and I would download a SLE Micro raw image and I would put it in the base images folder. And then I have a certificates folder. And so we talked about the private registry as a component, and that's where I need to use Hauler to serve up my registry of trusted components and artifacts. And so that's where I drop in all of these certificates in order to make sure that all of my nodes can trust that registry. And then in the custom folder, I have these files. So any files that I want to include in my image, I would put in this files folder. And so here I just have the standard RKE2 files. And then I put any scripts that I want to run when this image boots up the first time. And so, for example, my message of the day script is 96. And so for any government system, I have to have a banner that warns the user that they're on a government system. And so that's what I put in that message of the day script. And then you'll see I also have a Kubernetes folder here. Edge Image Builder can bootstrap an entire cluster for you. We don't use it that way because we like to have better control over how our clusters are provisioned, but you could do that. And then at the bottom there, you see what the final output is of Edge Image Builder. Now, normally we would use a GitLab pipeline to configure this. And so let me show you what a pipeline looks like. I'm just gonna go ahead and output that to the screen. So here's what a pipeline looks like. I just want to direct you at the bottom here. So how you do an Edge Image Builder is you run a podman command, and essentially what you're doing is mounting your configuration folder inside the container, and then you're passing in a definition file. And when you pass it that definition file, that's what it's going to read in, and it's going to build you your image. And so we usually create that definition file through use of templating. And so when it reads in that definition file, then it's going to create that raw image, and then we burn that image onto the hard disk. And when it boots up the first time, it's going to configure that server. And so I already did that. So we can go ahead and log into one of those machines real quickly. And you'll see that I have my message of the day screen here. And you can see that it's already been configured. And we can also take a look. You'll see that we also have RKE2 running. You can see that RKE2 is already running. So I'm going to exit out of here. Now, the other component that we talked about was hauler. And so we do have our registry running. Running your hauler registry is as simple as running a couple of hauler commands. And so one of the things we can do with hauler is look at what's in a hauler file that we built. And so I'm going to come up here, one folder, and I've got two folders here. I've got a registry folder and an RKE2 artifacts. And so if I drop into my registry, I'm going to go ahead and I'm going to inspect what's in here. And I'm going to say hauler store info. And you're going to see we have a bunch of containers. These are all my RKE2 Carbide components that I need to run a cluster. But then you'll also see I have some other things embedded here. These are some charts that we've embedded. This is from our stack builder. And then you've also see we've got our own trusted containers that we've embedded using stack builder. And you'll notice we've got attestations and signatures for all of those things. And so we can ensure that those things are trusted when they go to run on our cluster. So using policy enforcement like Kyverno, we can make sure that all of these things are entrusted. And so if they don't have a signature, they can't run in the cluster. And so this is how we enforce that all of our software artifacts or all of our containers and things like that are trusted. And so I'm going to come back up and then we're going to look at what's in a standard RKE2 bundle, and you'll see it's quite different. If we look in what's in a standard RKE2 bundle, completely different, just some standard Rancher containers. They're a lot different. And so you can see how hauler does a bunch of different things depending on what's in that particular bundle. And so the tooling plus the bundle is how we serve up that registry. And so it's the combination of building those images plus using the IBM stack builder to create that hauler bundle and then serving it up. And so if we come back onto our RKE2 server, I can show you by looking at, let me clear the screen just to make it easier. We'll look at the server logs here, and you'll see that our RKE2 server sourced all of its containers from the registry. And so how did we manage to do that? Well, we were able to override the behavior of RKE2 by setting its configuration when we built the image. And so if we look at what the configuration looks like, we can go look at the standard location for the RKE2 config. And you can see that we set the system default registry to our private registry here, which is being served up by hauler, and we've told it to source its stuff from registry.grayskull.local. Now, these nodes are air gapped anyway, so if I were to try and curl out to the public anyway, it can't get out, and so it wouldn't even been able to go out to the internet and get its containers from Docker anyway. But you can see from the logs that it sourced all of its containers from our private registry anyway. And so these are some of the ways that we're using the SUSE toolkit in order to be able to ensure that we have trusted components in all of our clusters from day zero, which enables that secure by default posture. And so I hope you found this tutorial helpful and give you some ideas on how you can use Holler yourself to build up your own secure by default artifacts and bootstrap your own clusters using your own secure by default bundles. Thank you.